In the last video, you learned a lot about Babel. We saw how Babel allows us to create JavaScript applications that work in a wider range of browsers, even if we're using those super modern JavaScript features. In this one, we're actually going to convert Boilerplate from just a set of scripts in a folder to a web application that we can actually view in the browser. Now, the first thing I want to talk about has to do with the Node Modules folder. If you remember from the last video, we never put anything inside of Node Modules, and we didn't even create it. It was created for us when we ran npm install with the package we installed, which happened to be the Babel preset env package. Now, what does this mean? Well, it means that we're not going to be keeping Node Modules around. Node Modules is a generated directory. So for example, if I was to give you a copy of this code, I wouldn't include Node Modules because it takes up a ton of space. Node Modules can be rebuilt by running a single command. So if you download the zip for this lecture or for any lecture in this section, you're not going to see the Node Modules folder intact. It actually gets deleted before I zip up the project, and what you get looks a bit like this. Now the question is, how do I get the Node Modules folder back so I can actually work with this project? And the answer is to run a single command. The command that you need to run is npm install. npm install doesn't actually require you to provide the package you want to install. We only do that if we're installing and adding something brand new. If you run npm install just like this with no package name afterwards, it's going to look in your package.json file and install everything in dependencies. So in this case, I can rebuild Node Modules from scratch by just running this command. I do not need to specify the specific modules or module versions because all of that lives in package.json. This makes it really easy to pass our projects around. When I give you a zip, I don't have to give you a huge Node Modules folder. You can get that back by cding into Boilerplate and running npm install. The end result is exactly what we had before. We have Node Modules back intact, and we're ready to continue on with the rest of the video. Now, the next thing I want to do has to do with the directory structure. So what we're going to do is create two folders. The first folder inside of Boilerplate is going to be called, as you might have guessed, public. So we still need a public folder that contains everything we want to serve up to our web server. The second folder that we're going to create inside of Boilerplate is going to be called source, SRC for short. Inside of here, we're going to put our JavaScript code before it was processed by Babel. Inside of public, we're going to put the JavaScript code that was processed by Babel. Because remember, things that go in public are the things that we use for the web application. And in this case, we want to use this file for our web app so it works in a wider range of browsers. I don't want to use this file, which isn't going to work if the browser doesn't support const, class, or any other feature we might be taking advantage of. So what does that mean for us? Well, first up, it means that we are going to move input.js into the source directory. So I can drag that inside of there. And I'm actually going to delete output.js from the root of the project altogether. Don't worry, we'll be recreating that in a moment by running a modified version of our Babel command. The next thing we're going to do inside of public is create a new folder called scripts. And this is where we're going to dump the output script. So all of the code we type lives inside of the source folder. Then the Babel output gets dumped inside of the scripts folder so it can actually be used by the web application. Before we go ahead and run the Babel script again, I'm going to change the name of input.js. I used input and output to make the last video easier to follow, but in the real world, I would most likely call this file index.js, the starting point for our app. So we have index.js here, and this is the file we now want to run through Babel. So let's go ahead and explore how we can set up the modified version of our previous command. So we are still going to start with Babel like we had before. No longer, though, can we just type the file name because the file doesn't live in Boilerplate. So if I used index.js, it would be looking for index.js in the Boilerplate folder. What we need to do is provide the path to that file. So for us, that is inside of the source folder, source/index.js. Excellent. Now from here, we do still have to provide the out file as well. So a space, out file. And then after another space, we provide the location for that. Once again, we don't just want to provide the file name because that would put it right in the Boilerplate folder. I want to put it inside of public so public /, then inside of scripts, so scripts /, then we can pick a good name for it. It is common to call this bundle, bundle.js. Now, after we set up the out file, we are still going to set up our presets, so space, hyphen right here, presets, space, env. Now we can go ahead and run our scripts and everything is going to work as expected because we've changed the paths to match up with our brand new directory structure. Over inside of Visual Studio Code, I have inside of public scripts the bundle.js file, and if I crack that open, it's the exact same output we had in the last one, which is a great first step. Now, if you're like me, you're probably pretty sick already of writing this command out in the terminal. So the next thing I want to do is give you a better way to run scripts when you're just going to be typing the same thing over and over again, like we would be here. This is using the scripts property in package.json. What we're going to do is copy the command exactly as we have it here. So I'm going to take this and copy this to the clipboard. Then I'm going to move over into package.json. And what we're going to do is look at this scripts property. Inside of scripts, by default, they give us a test script, which we're not going to be using. So we can actually gut that completely, setting scripts equal to an empty object. Then right here, we can set up some key value pairs, where the key is a shorthand name for what we're doing, and the value is the long form script. So in this case, I could say we are building our project JavaScript. So I'll call this our build script. Then as the value, I would set it equal to whatever I copied from the clipboard. So right here, I would paste the command exactly as I had it before. Now we can run this long command over and over again using this shorthand build. Let's see how we get that done from the terminal. Right here, all we have to do to get this done is use npm run followed by the script name. In this case, npm run build. If I run that shorthand, what do I get? I get the long script running behind the scenes, and we get the exact same output. So we're going to be using scripts anytime we have a really long command that we're going to be using over and over again. And in this case, the command that we use for Babel does take quite a bit of work to set up. So it is a nice idea to move this into scripts so we can refer to it by its shorthand build. And now that we have the build script in place, what I want to do is set up an HTML file in public so we can actually load the bundle.js file via a script tag and run the code that Babel spits out. Right inside of public, I am going to set up index.html, and in here, we're going to have our basic HTML boilerplate. Let's go ahead and set this up, starting with our doc type, setting it equal to HTML. Then we'll set up our HTML tag, and then we'll set up our head tag. In head, we can put title, boilerplate. App sounds like a pretty good title for this one. Then down below head, we're going to set up the body for the web page. Let's go ahead and add some test text inside of there, like an H1 with the text value of boilerplate. And then finally, we'll add in our script. So down below, I'm going to set up a script tag. We will load in an external script. So let's provide the source attribute. In here, we have to provide the path to that file. That is /scripts/bundle.js. When we provide paths inside of HTML, it's relative to the web server's root. We're going to be serving up public as the root, so / starts from public. We then go into scripts, and then finally we go into bundle.js. We could also make this a relative path if we wanted to. I could have ./scripts/bundle.js. This would work just as well. All right, we have our HTML file in place, so let's go ahead and test things out. Over inside of index.js, we are indeed logging something. I'm going to go ahead and use our class 2 just so we can prove everything works. I'll create an instance of this class, const hangman lowercase equals new hangman. Then I'm just going to call our one method. So console.log, and I will print whatever comes back from calling hangman.myMethod. I just want to add a little code inside of here so we can actually see things print in the browser's console when the web page runs. Now, it's important to remember that at this point, the bundle file has not reflected our changes. So over in the terminal, I can use the up arrow and enter to rerun our build script. Then we can use live server to serve up the public folder. So right here, we have live-server I'm going to serve up the public directory, and then we can view our app in the browser. Over here, I'm going to head over to 127.0.0.1 on port 8080. When I view that page, what do I get? I get my boilerplate app showing up. We have our H1, we have our title correct, and then we can crack open the dev tools to make sure the console shows the correct output as well. I'm going to go over to the developer tools and crack open the web console. Right here, I see gen, which is coming from the variable we created using const. Down below, I see testing, which is coming from us using the class created with the class syntax. So here we can see that when we run bundle.js, our application is still working as expected. It's now working in browsers that it would have already worked in, but it's also going to work in a wider range of browsers used by other people. When we add tools like Babel into the mix, we get nice advantages, but obviously it makes our local workflow a bit more complex, but it's not as bad as you might think. I'm going to switch over to the terminal, and what we're going to do is leave this up and running. I'm going to leave live server as it is. I'm going to create another terminal window or terminal tab, and we're going to make sure we are still in the boilerplate directory. So I have one tab running live server. I have another tab currently doing nothing. This is where we are going to run that build script. Now, I don't want to have to run build every single time I make a change to index.js. That would require me to switch back and forth between programs, and it pretty much defeats the purpose of live server automatically refreshing things. The good news is that we can make a small change to our script to actually have Babel watch for changes. So let's go ahead and explore how we set that up. Over inside of package.json, all we have to do is add on a new option. So right at the very end of the script, I'm going to add a space, then 2 hyphens, followed by watch. When we add on watch, it is not going to just run Babel once. It's going to run Babel once, then it is going to watch the input for changes. When the input changes, it is going to rerun Babel and generate a new out file. So with this in place, we can now automate our workflow. I'm going to save package.json. Over inside of the terminal, we're going to run that script, npm run build, and we're going to notice that it doesn't bring us right back to the terminal like it did before. It's actually watching and waiting for changes. Much like live server doesn't bring us back to the terminal, the server is still up and running. The nice thing though is that now we can make changes to index.js. When we make those changes, Babel is automatically going to compile a new bundle.js file. Live server is going to see bundle changed, and we are going to see the latest in the browser. To prove this, let's go ahead and change something that prints down below. I'm going to change the name from Jen to Mike. I'm going to save index.js, and we can see that in the background, we now have the latest version of our web app running with Mike printing as opposed to Jen, and that all happened in real time, just like we were seeing before. The only difference is that this time around, we're using Babel, which means we need a second command running in the terminal, but that is definitely worth the trade-off. And that's where I'd like to stop for this one. Let's take a quick moment to recap what we did. In this one, we started by changing the directory structure for our project. The public folder contains our public assets like index.html and any images or CSS we might have, and it also contains the compiled version of our JavaScript. All that lives in public. In source, we have all of the JavaScript that makes up our application. Currently, that's just one file. Don't worry. We'll learn how to break that up into multiple files that all work together in a little bit. In the end of the day, though, this gives us a nice structure, and we now have a way to actually build out our apps. Over inside of package.json, we also created a new script called build. This is just a shorthand. It gives us an easy way to run a much longer script, so we don't have to type this longer script out over and over again. We've made some good progress so far, but there is still a lot more to cover. In the next video, we're going to continue talking about our project setup.